Hello class, this is Math 1430 and we're just going to review sections 5.1 and 5.2 together. And all it is algebra review, stuff you already know for exponentials and logarithmic functions. And here are the 5 problems. So let me step back here so you can see all 5. We're just going to go over these 5 problems. Number 1 is solving an exponential equation. Number 2 is solving a natural log equation. When you see ln, that means log base e, natural log. Number 3, we're going to evaluate multiplying where you see an exponent. Number 4 is using the rules of exponents as well. And number 5, what happens when you are dividing with exponents that have the same base. Okay, so my brother Doug is going to take care of these while I tape them. Record me. Hello! Let us make short work of this. So, I want to solve for t here. Let's factor it first. What's the greatest common factor of these two terms? It appears to be e to the t. And what am I left with? With the first term, t, and minus 1 equals 0. If you're not sure you factored correctly, use the distributive property here. Do you get back upstairs? And indeed we do. So it's factored correctly. Now let's use the zero factor property next. Set each factor equal to 0. When I set that first factor, e to the t equals 0, there's no real number answer for t here. E raised to any real number will always give you a positive answer. So this is impossible. So reject this one. And then what about the other factor? And it looks like t equals, add 1 to both sides, you get t equals 1. So that is the answer. T equals 1 will make this equation true. In fact, what do you get? E minus e equals 0. Yeah, that's true. Okay, let's do this log equation. I like to rewrite ln as log base e of the argument x minus 2 equals 5. It's just easier. I like to see the base in front of me. And how do you solve a log equation? Bebop to its equivalent exponential form. So what's the equivalent exponential form? What's my base going to be for the exponential form? The same as the base of the log, e. Logs are equal to the exponent. So in exponential form, isn't that where the exponent goes? And then equals whatever's left, the argument. And we want to solve for x here, so add 2 to both sides. I love that symbol, the double arrow, continuing my thoughts. And when I add 2 to both sides, I get e to the 5th power plus 2 equals x. And that's good enough for that. That's the exact answer there. And I'll do the last 2 just for variation. So this is the twin brother Dave. And number 4, the temptation is to do 4 times 9 is 36. But you can't do that because exponents have priority over multiplication. So let's say this is equal to 4 times, and the root is on the bottom. So this really means you take the square root of 9, and then with that result, you cube it. Another way of thinking about it is put this into radical form. So instead of using an exponent, draw a radical sign if you want to do it this way. It's up to you. So 9 is the base, and the root is 2, which I don't have to write. It's understood to be a 2. The power, which is up high, is 3. So then this is going to equal 4 times, and let's do the square root first to make the number smaller, and then I'll cube the result. So the square root of 9 is 3, and then we got to cube that. So this is going to be 4 times 27. 3 cubed is 27, and that's 108 for my final answer. Okay, this one here, each factor, I got 3 factors here, get raised to the 2/3 power. That's a property of exponents. Each factor gets raised to the power. So this is going to be 8 to the 2/3 times, and now I'm going to use another rule of exponents. A power to a power, you multiply. So I'm going to write m, and then when I multiply the powers, 3 times 2/3, that's just 2 because the 3's cancel, times n. And then what? And then a power to a power you multiply. What's 6 times 2/3? Let's do this. This means divide. So divide 3 into 6, you get 2, and then multiply it by the numerator. 2 times 2 is 4. And then this is going to equal the root is on the bottom. So instead of writing in radical form, I'm just going to do it directly. What is the cube root of 8? That's going to be 2. And then the power is 2 times m squared n to the 4th. And that's just going to be 4m squared n to the 4th. That's my final answer. Make the exponent look like an exponent. Put it up high and small. Okay, and then finally, I want to simplify that denominator before I do anything. So the numerator cannot be simplified, but the denominator is going to be the base is x, power to a power, you multiply. Now I can use another rule of exponents. Whenever you have the same base in division, you keep that base and then you subtract the exponents. So it's the top exponent, n plus 4, minus the bottom exponent, which is 6n. And finally, we get our answer of x raised to negative 6n plus n is a negative 5n plus the 4. And that's my final answer. Okay, that's all. Good night, everyone.